You're standing in a cabin in northern Wisconsin. It's 11 below outside. The fire in the corner burned out 4 hours ago. No wood stove glowing, no flames, nothing. The room is still warm enough that you've taken your jacket off. Your hand rests on a curved clay bench, still warm enough to nap on. One armful of wood, burned for 90 minutes this morning, is still heating this room at midnight. That bench is called a rocket mass heater. It burns wood so completely that almost none of the heat escapes up the chimney as smoke. Instead, it gets trapped in a few hundred pounds of clay and stone, which release it slowly for 12 to 24 hours, long after the fire is out. By the end of this video, you'll understand exactly how this works, what it costs to build, and whether it makes sense for your situation. No masonry experience required. Here's what most people get wrong about wood heat. A standard fireplace is one of the least efficient ways to burn anything. Most of the heat goes straight up the chimney, along with most of the smoke, because the fire never gets hot enough to fully combust the wood. Even a good EPA certified wood stove typically runs 65 to 75% efficiency. The rest is lost heat and unburned particulate. The rocket mass heater attacks that problem differently, and the idea didn't come from a fireplace manufacturer. It came from an engineer trying to solve a problem on the other side of the world. In the 1980s, Dr. Larry Winiarski at Aprovecho Research Center in Oregon was designing a cook stove that would let families in developing countries cook using a fraction of the firewood they normally needed. He found that forcing flame and smoke through a narrow, heavily insulated vertical chimney right above the fire, called a riser, creates a strong draft that pulls in exactly the air needed to burn the wood almost completely before it leaves the firebox. That insight became known as the rocket stove principle, now used in cook stove programs across dozens of countries, specifically because it cuts wood consumption and smoke exposure. A few years later, builder Ionto Evans took that combustion core and asked a different question. What if, instead of cooking, you ran the hot exhaust through a long horizontal duct buried inside a bench of clay, sand, and stone? The mass would soak up heat from that short, intense burn, then radiate it back for the rest of the day. That's the rocket mass heater, a fire that burns hot and fast for an hour or two, and a bench that stays warm long after. The physics is straightforward. The firebox sits low, feeding into a vertical insulated riser. That riser creates a powerful draft, since hot air rises, and the insulation keeps the inside extremely hot, driving complete combustion. From the top, exhaust gets pulled down and sideways through a horizontal channel, sometimes called the manifold, snaking through stone, clay, and sand, often shaped into a bench. That mass absorbs the heat before exhaust exits through a much cooler final chimney. By the time smoke leaves the building, it's lost most of its heat to the bench and most of its particulate to the complete combustion in the riser. Builders and researchers who have run combustion tests on these systems document efficiencies well above a standard wood stove, with exhaust sometimes nearly invisible compared to a typical campfire or open fireplace. Here is why that matters for your woodpile. A family heating primarily with a conventional wood stove through a hard winter might burn 4 to 6 cords. Builders who switch to rocket mass heaters consistently report cutting that by half or more, since so much less energy is wasted as unburned smoke. Less wood cut, hauled, and stacked for the same number of warm nights. So why is this not in every off-grid cabin in America? The honest answer is not a hidden conspiracy. It is a paperwork problem. The Environmental Protection Agency's emissions standards for wood heaters were built around factory-manufactured stoves, identical units easy to test once, and certify nationwide. A rocket mass heater is almost always owner-built, out of local clay and stone, varying slightly from one builder to the next. There is no factory model to certify. That leaves it in a regulatory gray zone in many jurisdictions, not banned, just unaddressed, which means permitting often comes down to your specific county and inspector. Counties with active natural building or off-grid communities, parts of Oregon, Montana, and the Ozarks, tend to have inspectors who have seen these before. Counties that have not encountered one sometimes default to no, simply because there is no checkbox for it. That is not suppression. It is a system built for factories, trying to evaluate something built by hand. If you are the kind of person who would rather build it once than pay for it every winter, subscribe now, because that is exactly what the rest of this channel is about. Picture a homesteader in rural Vermont with a drafty farmhouse from the 1930s and a propane bill that used to run close to $300 in some winter months. After building a rocket bench along one wall, that household now runs the propane furnace as backup for the coldest nights only, burning about half the wood they use to feed their old stove. The bench takes roughly 90 minutes to heat up, then holds steady warmth through the afternoon and evening without anyone tending it. That's the kind of result builders in these communities report again and again. Not a miracle, just a fire that finally burns the way the physics says it should. If that sounds appealing, you deserve to know where this doesn't fit. If you live in an apartment, rent your home, or don't have clear access to run a chimney through an exterior wall and roof, this isn't buildable. If your jurisdiction has no history of permitting owner-built masonry heaters, talk to your building department before you start, not after, since retrofitting a permit afterward is far harder. And in a tight modern home with minimal clearance to combustibles, you'll need real expertise on sizing, since a few hundred pounds of hot mass too close to a wall stud is a genuine fire risk. This is a project for people with some space, some time, and a property where they plan to stay. For everyone else, here's what Building 1 involves. Step 1. Plan your footprint. A typical bench-style heater needs roughly 6 to 8 feet of horizontal duct run and 20 to 30 square feet of floor space. Sketch the path from firebox to final chimney before buying anything. Step 2. Build the firebox and insulated riser. Use a few fire brick or a ceramic fiber-wrapped metal pipe surrounded by perlite or vermiculite insulation. Expect roughly $80 to $150, depending on size. Step 3. Lay the horizontal exhaust duct, often stovepipe or a clay and sand channel, through what will become your bench. Slope it slightly upward to keep the draft moving. Step 4. Pack the thermal mass around that duct, typically a cob mix of sand, clay, and straw, or stacked stone and mortar, built into a bench shape. Often locally sourced, this can run $100 to $200 depending on hauling needs. Step 5. Install the final exit chimney, a code-compliant stovepipe through the roof or wall, sealed at every penetration. This is where new code-compliant materials matter most, typically $100 to $200. Step 6. Cure and test burn. A mass heater needs to dry slowly over 1 to 2 weeks before its first full burn, or trapped moisture can crack the cob. Start small and work up. Step 7. Commission it properly. Run a full heating cycle, check for smoke backdraft at startup, and confirm the bench surface stays comfortable, generally under 140 degrees Fahrenheit, where you will sit. Total materials for a modest build typically land between $400 and $800, mostly fire brick, stovepipe, and insulation, since the bulk of the mass is often sourced on site. Compare that to a several $1,000 high-efficiency wood stove installation, plus the wood you will keep buying every winter, regardless. The rocket stove principle did not come from a marketing department. It came from an engineer trying to help families burn less wood for the same warmth. The physics has not changed since the 1980s. What has changed is that almost nobody's building department has caught up to it yet. So here's what I want from you. If you've got a wood stove right now, tell me in the comments how many cords you burn through a winter and what your county is, because I want to track which jurisdictions are actually permitting these. And if anyone in your family heated with a wood cook stove or a Franklin stove, tell me what you remember, because some of those old habits turn out closer to this than you'd think. And if you want more of the build-it-yourself side of energy independence, subscribe, because next week I'm walking through a root cellar design that holds a steady 50 degrees year-round, using nothing but soil depth and airflow, no electricity at all.